Now let's go over motion blur threshold. Well, as you can see in this slide, motion blur threshold is your friend because it can really allow you to get very good quality motion blur and while still keeping the actual render time quite decent. Just to give you an example here, right now in this example we see that anti-aliasing minimum and maximum has been undersampling. They use negative value, -3 and -1. The motion blur threshold in this case is 0.006. It's going to be very, very fine. It took about 10 seconds to render this simple image. As you could see, because the anti-aliasing is so low, we get actually jaggies here, because keep in mind that motion blur threshold is basically determining the quality of moving object, where anti-aliasing threshold determines the quality, the render quality of static object. So in this case, I'm doing a very poor job at static object settings. In this case, every object that appears to be still, like here, or actually the actual dog head here, looks a little bit jaggy. We can actually resolve that by increasing the anti-aliasing to -20, so at least one pixel. Each pixel has been sampled at least once. So as you can see here, we actually resolve the jaggies here, and also we keep the rendering still quite decent. 30 seconds for an image like this is quite good. Let's go back in XSI here to demonstrate this concept. Now under the render options here, I've set up this particular example here to demonstrate that motion blur can indeed do a lot of good in your scene. So I've set up this very simple scene. As you can see, it really renders quite rapidly here, but we still see this particular artifacts here. So if I increase this to, let's say, 0-3 for example, now it takes a little bit more time to render, but it will resolve these artifacts right here and these artifacts right here. So now we get a very, very good render. Obviously in production, it's always a blend between static object and moving object. So this particular setting is not good for a blend of static and moving. You could use this if, let's say, for example, you have an object that always move throughout the actual animation sequence, and none of the actual moving object parts are standing still. So you could use that, and that could actually improve the rendering time. Let's say you're rendering digital mattes background where you have a flying camera and you're doing camera projection, then obviously you could use this trick to blur the matte and still keep a very good quality and keep the render time quite under control. Now, as you can see here, the actual anti-aliasing here is quite fine. So we're forcing more like the actual anti-aliasing to be 0. So in this case, I'm going to actually make the anti-aliasing threshold very poor. So I'm setting the anti-aliasing to be very, very, very lazy. Okay. So now if I go to motion blur here and I set also the actual motion blur threshold to be lazy. So it's always to keep a balance between the two. Some people have been asking, shall I set the actual motion blur threshold lower than the anti-aliasing or higher? The idea is that anti-aliasing calls motion blur. If motion blur does a poor job, anti-aliasing will try to recuperate from this poor job, try to fix it. But obviously anti-aliasing is not designed to do motion blur, so it will not actually fix the problem. So it's really important to keep the motion blur threshold lower than anti-aliasing threshold. So let's keep this value very, very small. So now as you can see here, I'm really motion blurring and still keep the actual rendering time. If I go here under anti-aliasing and I start to lower this, I'll start to resolve these artifacts here by lowering this value and pushing more towards 0. Now I'm starting to resolve this value here. So if I lower this, these problems will basically eventually all disappear and will all look much better in terms of render. So as you can see now, I'm starting to, now if I really push it a little a little bit further, then obviously the actual rendering will take a little bit more time. So as you can see here, because he has to do a little bit more work, there's more sample being taken. So instead of skipping pixel, it's going to actually sample one pixel once. So as you can see, this line looks much better now, and all these things here will actually look also much better. So you could see here we have this actual result. Here it is. So this is actually the how to use motion blur threshold and anti-aliasing. And keep in mind that balancing well motion blur and anti-aliasing will allow you to get a good quality while keeping your render time as low as possible. Also, another factor is that the threshold here is also dependent on the actual shutter. So if you do have a very small shutter, for example, then what's going to happen here is that we have pretty much a good balance between a static and a moving object. So in the case where the motion blur is pretty small, now we have to let the anti-aliasing do a little bit more work in this case, because it's like if the object was standing almost still. So we have to basically balance and let the anti-aliasing do a little bit more work in this case. So it looks pretty good here. We don't have that much problem. So I think it's quite decent. In this case, you may want to increase it to -1, and that may resolve some of the artifacts you may see. Let's go back here to motion blur and set it back to 1. And I'm going to go in anti-aliasing and lower this thing -20, so we can have a sense of the moving object. Now the motion blur step, that is a new feature that's been exposed in XSI 3.5.1 and XSI 4.0. The interpolation step allows to take let's say, for example, an object that has a given SRT at the beginning of the frame and a different SRT at the end of the frame, and actually, instead of doing a linear interpolation between these two SRTs, scaling, rotation, and translation, it will create in-betweens such that you, instead of having something that looks linearly interpolated, it will look rounded. So for example, if you want to use propellers having let's say a plane propellers having very roundy motion blur, you would use the interpolation step to create this thing. Keep in mind that also this has a cost, so it's going to also increase the actual rendering cost, because instead of doing a linear interpolation, he has to create these in-betweens, and these in-between has to be stored in memory, and that has an effect in terms of memory and also memory demand.